Okay, so in the previous session, we discussed about the functionality of this background process called database writer. Okay, and we also discussed the functionality of log writer process, which is represented by LGWR. Okay, and then we also saw the functionality of archiver process, which is represented by ARCN. Okay, so now if we these three processes, out of these three, this database writer process, it this one and the archiver background process, it is represented as it has an N in their name. Okay, at the end it has got a N in their name. So why is it so? That's because we can configure multiple database writer processes and multiple archiver processes in the database. Okay, that's why they are represented as ARCN for archiver and DBWN for database writer. Okay, now one question might be, why should there be, or why would there be a requirement to configure multiple database writer processes? Okay, so if your database is a highly transactional database wherein the users are continuously modifying the data in the database, or the flow of new data coming into the database, it is very high. Okay, so in those scenarios, a single database writer process may not be able to keep up to the speed at which new data is coming into the buffer cache. Okay, so if in the buffer cache there is not enough free buffers available or empty buffers available, in that case it will again be a problem, right?
Yes,
So Oracle has to ensure that at any given point in time there are enough free buffers in the database buffer cache as well. Okay, so to keep up to the speed at which the users are either modifying the data, modifying the existing previous data, or the speed at which the users are trying to insert new data in the database, to keep up to that speed, you as a DBA, you might need to configure multiple database writer processes. Okay. And then the same concept applies to the archiver process. So we said that the archiver process, it creates something called as the archive log files. And how does it create the archive log files? By copying the contents of redo log files. Correct? We looked at this diagram. Okay, we looked at this diagram and we said that the job of the archiver process is to copy the archive log files at every log switch. So log switch is when LGWR was writing to this redo log group, it finished all that 500 MB that is allocated to this redo log group, and it switched to this group. Okay, that is called a redo log switch, switching from one redo log group to another redo log group. So when LGWR background process makes a switch, at that time, the archiver background process will get activated and it will copy the contents of this redo log file and create something called as the archive log files. Now, if your database is again a highly transactional database, in that scenario, what will happen is, again, the number of redo entries that are getting generated in the redo log buffer will be very high, right? So LGWR is writing all those contents to the redo log files. Okay, it made a redo log switch, it came back over here. Now again, it has to come back to log group 1. Okay, but meanwhile, archiver background process, its job is to copy the redo log entries from this file to archive log files. But again, it might happen that it is not able to keep up to that speed. Okay, if the archiver process is not able to keep up to the speed at which LGWR is writing to the redo log files, then in that scenario, you as a DBA, you might need to configure multiple archiver processes. Okay, and that's why it's represented as ARCN. You understand that, Azaz and Mahesh?
Yes.
Yes.
Multiple archive log files.
Yeah, so based on not the archive log files, number of archiver processes. Okay.
Okay.
Now that number of processes, Oracle, they have kept on increasing it. Okay, there was a time when in Oracle 9i, there was only, we could only configure 9 dbwr processes. Okay, then they increased it in 10G, then again increased it in 10G. Now in 18C and 19C, it is like more than 25 or 36 dbwr processes. The same thing applies to archiver as well. Okay, so you won't need to configure more than a few, like 2 or 3 archiver processes. Okay, for that matter, I haven't come across many scenarios wherein there are more than one archiver process configured in the database. Okay, and the same applies to the database writer process as well. But at the same time, you also see in the architecture diagram that this LGWR background process, it is not being represented as LGWRN. Okay, that means we cannot configure multiple log writer processes. Okay, in any versions of Oracle database until now, we cannot configure more than one LGWR background process. Okay, one more thing that you should remember about LGWR process is that LGWR will parallelly write whatever information it will write in this redo log file 1, same information it will write into redo log file 2 as well. Okay, so when you are going to create a redo log group and you assign it a size of 500 M, it means that the size of both of these redo log files, or which is called as redo log member, both of them will be sized 500 M, and LGWR will write the same information which is going to write on this one. It will write the same information on this one as well. Okay, clear with that?
Yes.
Yeah, so we discussed this much until this much in the last session. Okay, the next background process that we are going to see today is something called as the PMon and PMan. Okay, PMon stands for process monitor. Okay, and PMan stands for process manager. Okay, now what happens in case of PMon, or what is the functionality of the PMon process? Let's go back to our example wherein we said that, say, there is this user Mahesh. Okay, Mahesh fires an update statement. Update employees, set salary equals to, say, some number. Okay. Okay. Where emp underscore id equals to 123. Okay. Now when the user fires an update statement, Oracle has to apply a lock on this specific row. Okay. Let's say that in your, where is our previous example Excel? The table, these are the values that are placed in, say, uh, get this. EMP ID, name, salary. This is how your table looks like. Employee ID 1, 2, 3, name is say ABC, EDF, whatever it is. Okay. Salary equals to 1, 2, 3, 4, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay. So let's say this is how your table looks like. Okay. And the user Mahesh wants to update say this specific employee ID's data. Okay. So when the user fires the update command, Oracle applies a lock on this specific row. Okay. Oracle has to apply a lock on this specific row. Why? Because this specific row, it needs to be updated by this specific user. So the user has fired the update command. Now, unless and until the user fires the commit statement, or else the user fires a rollback statement. Okay. Commit means the user wants to permanently save the data. The user wants to permanently store or permanently save the modified data in the database. So that's how a user fires or the user saves the data permanently in the database by firing a commit statement. Rollback means the user wants to undo. Okay, the user wants to undo the changes that he has made in the database. Okay, you understand what is the difference between undo and redo? Okay, we'll discuss about that. Undo and redo. What is undo? Undo is you want to roll back your activities in the
Previous
database.
operation.
Yeah, you want to negate whatever update or delete or insert statement that you have fired in the database. So you perform a rollback. The rollback internally, you are saying that I want to undo whatever changes that I have made in the database. Okay. Whereas redo is something that you want to perform
No,
the
reperform.
exactly reperform. So the redo term will come into picture only when we are discussing the redo log buffer or redo log groups. Okay. I just wanted to make a differentiation between these two terminologies. Okay. Undo and redo. So if you want to undo your changes made into the database, the user has to fire a rollback command. Okay. So let's say that the user had fired an update statement, but the user, after firing the update statement, the user has not yet committed it. Okay. Let's say that this command was fired at 4:30. Okay. And until 5 p.m., the user has not yet committed his transaction. Okay. The user has not yet fired the commit until 5 p.m. That means Oracle has to apply the lock on that specific table. The lock has to be kept applied on that specific row until and unless the user has either fired a commit or a rollback. Okay. Now it might happen that before the user has fired a commit or rollback, before the user has either fired a commit or a rollback, his transaction got disconnected. It is possible, right? The user's application crashed. There was some network problem due to which the user's session got disconnected from the database. These things can happen, right?
Yes,
Mahesh,
sir.
okay.
Yes, yes, sir.
So
Hearing.
because of any XYZ reason, if the user did not get a chance to either commit or roll back a transaction, okay, and the session gets disconnected, in that case, the PMon process, which you see in this diagram, the PMon process will have to perform a cleanup of the logs. Okay. What the PMon process has to do, it has to perform a cleanup of the logs, because if that log does not get cleaned up, okay, it means that no other user will be able to make changes to any row in any data in that specific row. You understand that?
Sorry.
See, if the user had acquired a lock on this specific row because he wanted to update it, okay?
No one
Now,
can perform
yeah,
any other
so
operation.
exactly. So if the user who has acquired a lock on this specific row, if the user did not get a chance to commit his transaction or roll back his transaction, okay, and his session gets disconnected or he disconnects it by himself. In that scenario, what should happen to this specific lock? It can't.
It will be locked.
Yeah, yeah. So
It will
it
be
is.
locked.
Go on. Sorry.
It will be locked until he commit the
Shared lock,
transaction.
shared lock will be happen on that one.
No, so shared lock will not happen in case of update statement. Okay. Because it is an update statement, the user will get an exclusive lock on that row.
Sorry, exclusive.
Okay. So exclusive lock will be. So because the user has exclusively locked that specific row, no other user can fire a DML statement on this specific row. Okay. So what Oracle has to do is, if the user who had acquired an exclusive lock on this row, if the user could not commit or roll back his transaction, in that case, the PMon process has to come into picture and it will have to release all those locks, release all those transactions, clean up all those transactions. Okay. Clear with that?
Okay.
Yeah. So that's the job of the PMon process. Okay. Then there is this PMan process, process manager. The job of the PMan process is primarily to restart any of the failed background processes. Okay. If there are any failed or because of some XYZ reasons, any background process gets terminated. Okay. The job of the PMan process is to restart those killed or failed processes. Getting it?
Yes.
Yeah. So that PMan process again will come into picture specifically for the optional background processes. Because if any of the mandatory background processes fail in the database, okay, if any of the mandatory background processes fail in the database, like your DBWR background process or LGWR background process, okay, or even for that matter, PMon as well, your instance will crash, your database instance will crash. And that's why they are called as the mandatory background processes. For your Oracle database to remain functional, for your Oracle database to be to remain available to the users, these mandatory background processes will have to be running. Okay, they should be functioning as normal. If there is a problem with any of these mandatory background processes, you as a DBA, you will start noticing problems in the database, and eventually your database instance will crash as well. Okay, or it will get hung. Some you will start facing problem with the database. Okay. So PMan, like I said, it will restart some of those it will restart the failed background processes, but they will mostly be the optional background processes only. Okay. So that is about PMon and PMan background process. The next background process, mandatory background process that we see here is SMON, which stands for System Monitor. Okay. So what is the job of this System Monitor background process? It has a very critical functionality of performing the instance recovery. Okay. Now this is your instance that you see in this diagram. All this is your instance. Where is the instance present? Where is this loaded?
Memory, in memory.
Yeah, it is loaded inside the server memory. So if for some reason, let's say that your server crashes, or the servers crash, right? From time to time, you might face issues that the server crashed, okay, because of some high CPU utilization or memory utilization. You will face these scenarios, okay. So if for some reason your server crashes, or there will be some scenarios or occurrences wherein your server will remain fine, okay, there will not be any problem with the server because of some or the other issues within the database instance itself, your instance will crash, okay. Now if the instance has crashed, that means what will happen to all the dirty buffers that were present inside the database buffer cache at the time when the instance crashed? Okay, we always say that the database writer process, it keeps on writing the dirty buffers from the database buffer cache to the data files. But there will be scenarios wherein there were some dirty buffers which were yet to be written to the data files, but the instance crashed, correct? Or it might also happen that there are some redo entries present in the redo log buffer which were not yet written on the redo log files, and your instance has crashed. Okay. So in that scenario, when you are going to reboot the server, or when the server is going to start again, okay, in that case, something called as an instance recovery has to be done. Okay. When the database instance was not closed properly, okay, like in case of SQL Server also, you must be you must be shutting down the database cleanly, right?
Yes.
Correct, Azaz or
Yes,
Mahesh?
sir.
Yeah.
Yes,
So
sir.
if the database has not been shut down cleanly, okay, if the instance crashed, next time when you are going to start the database instance by yourself, or if it has been configured in a way that it will come up automatically when the server boots up, that time the instance recovery has to be done, and that instance recovery is taken care of by the SMON background process. We will look into all the stages of instance recovery in detail at a later session. But at this moment, just understand that it is the job of SMON background process to perform instance recovery in the database. Okay. And when does instance recovery, in scenarios wherein your Oracle database was not shut down properly? If the instance terminated abruptly by itself, or if the server had crashed, in those scenarios, instance recovery has to be done. Okay. The next background process we are going to see is this LREG, which stands for listener register. Okay, what is the job of this listener register? Again, it has got the term listener in its name. That means it must be doing some or the other functionality related to the listener process. Okay, so what does it do? Whenever a database instance is started, okay, the LRAG background process of that specific instance, okay, it will let the listener know, that this database instance is now up, okay, so that if a user wants to connect to that database instance, the listener is aware that, okay, this instance is running. You understand that?
Yes, sir.
Yeah. So in the earlier sessions, we said that whenever the user wants to connect to the database, this connection request is first accepted by the listener. So the listener will then connect the users to the database instance. Okay. But then how does this listener know that this instance is running or not. That is the job of this LRIG process. It will register this database instance to the listener. Okay. Clear
Okay.
with that? Yeah. Okay. The next background process we are going to see is something called as the RVWR. Okay. So what is the job of this RVWR? We see this memory area called as flashback buffer. We discussed about that in our last session. So flashback buffer is a functionality, is an optional functionality in the database. Okay. If you enable this flashback database feature in the database, what will happen is dirty buffers from the database buffer cache, they will get copied to the flashback buffer. And then from the flashback buffer, they need to be written down into something called as the flashback logs. So it is the job of this RVWR process to read the flashback buffer from time to time at specific events and write them into the flashback logs. Why do we make use of the flashback database feature? So that if you want to go back to a previous point in time, okay, we took this example wherein we said that if there is some failure in the database at say 8:59 a.m., right? If there is a failure in the database at 8:59 a.m., okay, and you want the database to be taken back to exactly at that specific time, okay, if you want the database to be taken to a previous point in time, you can make use of the flashback database feature. Okay. Now, provided that will be possible only if you have enabled the flashback database mechanism. Okay. Or the other option is to perform a backup and recovery, to perform a restore and recovery. We discussed the restore and recovery scenarios example, right? We discussed about that.
Yes.
So what is the difference between a restore recovery and a flashback database mechanism?
Restore recovery means restoring a existing backup and database making online.
Okay. What is, so how does it differ from flashback database?
Flashback database means it's whenever it is crashed, at the time it will be used.
No, no. The difference between flashback database and restore recovery is in case of flashback database mechanism, you are not required to restore any backup. If you recall, I mentioned this point in the previous session. Okay.
Yes.
In
Flashback
case,
database should be before at the time. We can mention at the time.
yeah, so we will fire a flashback database command in the database, okay? But at the same time, you will not be required to perform any restoration from the previous backups. We don't require the previous database backups to be restored if you have enabled flashback database mechanism in the database, okay?
Okay.
So we make use of the flashback database mechanism on specific scenarios like when you are going to perform a database upgrade. That time Oracle suggests or Oracle will recommend that you should enable flashback database mechanism just before you are going to start your database upgrade activity. So that if there is something wrong that happens during the upgrade, you can straight away fire a flashback database command and it will take your database back to as it was just before the start of upgrade activity. Now, if you don't do that, okay, if you don't do that, there are different set of steps that you will have to take, okay, and those steps will be very much time consuming. So flashback database is the easiest option for taking your database to a previous point in time. Okay. So that is the job of this RVWR background process. It will get activated from time to time at specific events, and it will copy the dirty buffers from flashback buffer to the flashback logs. Okay. The next and another very critical background process that we are going to see is called as the checkpoint background process, okay, which stands for CKPT. Now, what is the job of this CKPT background process? The CKPT background process, it from at periodic events, okay, at specific events, it writes something called as a checkpoint information, okay. The checkpoint background process will write something called as a checkpoint information into the control files and the data file headers, okay. I'll just mention it over here again. CKPT will write the checkpoint information to the control files and the data file headers. Okay. So understand this, that the checkpoint information is written to the control files and all the data file headers. Okay. So we have got something called as control files in the database. Okay. And of course, you have seen the data files as well, which is going to physically store all the data in the database. So these data files, they have got a section called as data file header. Okay. So that checkpoint information will be written in the data file headers and the control files. There will be multiple control files. All the control files are going to hold the same information. Okay, so whatever may be the number of control files that you are maintaining in your database, okay, all of them are going to have the same information. That means they are, when we are representing it like this, they are multiplexed copies of the control file. Okay, so what is that checkpoint information? Why is it required? Okay, so when we say that this SMON background process, coming back to this SMON background process, we said that the SMON background process will perform the instance recovery. How does it perform the instance recovery? To perform that instance recovery, basically the SMON background process will have to read that, or it has to identify the checkpoint information which is present inside the control files. Okay, so SMON will be able to perform the instance recovery only when it is able to get that checkpoint information from the control files. Okay, so that's why the CKPT background process, it will have to keep on updating the control files and data file headers with the checkpoint information. Is it, have you guys understood this CKP, the relationship between CKPT and SMON background process?
Repeat once, Dhruv.
Yeah, sure, no problem.
Mm.
So I said that the checkpoint background process, it will write something called as a checkpoint information into the control file and data file headers. Okay. Why is that information required? What is that checkpoint information? Okay. So basically that checkpoint information is required for the SMON background process if SMON has to perform an instance recovery. Okay, let's say that this instance gets crashed. Okay, if the instance gets crashed, in that case, we said that SMON needs to perform the instance recovery, but the SMON will be able to perform the instance recovery only if it is able to read that checkpoint information from the control file. And who is responsible for writing that checkpoint information in the control file? It is the job of your CKPT background process.
Yes. Yeah.
Okay, so that is the relation between your CKPT and SMON. So SMON is pretty much dependent on your the functionality of CKPT. Unless and until CKPT has written the checkpoint information into the control files, SMON will not be able to perform the instance recovery. Okay.
Yeah.
And that checkpoint information, if that checkpoint information is not available, somehow if that checkpoint information is not available in the control files, instance recovery cannot be performed by by any measure. Okay. So that is about the CKPT background process as well. And again, you cannot configure multiple CKPT background processes. There is going to be only one CKPT background process for every instance. Okay?
For one instance, only one CKPT only.
Yes, exactly. There can be only one CKPT process, and it will write that that checkpoint information into the multiplexed copies of the control files.
Yeah.
Okay. The next option.
Checkpoint knows when the instance will restart. You also know that one. No?
No, checkpoint doesn't have to bother about that.
Yeah,
Okay, checkpoint's job is to it will get activated by default. It will get activated after every 3 seconds. Okay, that
Yeah.
is the most frequent event, and at the same time there are other events as well at which it gets activated. So the most common will be after every 3 seconds. So after every 3 seconds it will write that checkpoint information in the control file. Okay.
Okay.
And that checkpoint information will be required primarily only when SMON has to be SMON has to perform the instance recovery. Okay, understand this much at this point in time.
Yeah.
So the another optional background process that we will see is this CJQ0. Okay, so these are the scheduler processes in your database. You can configure multiple scheduled jobs in the database. Okay, so all those scheduled jobs will be triggered through these CJQ background process, and they are optional. They are not mandatory processes in the database. If you as a DBA or if some developer wants some activities to be scheduled in the database, then these come into picture. Clear with that?
Yes.
With this, we finished all the background processes. Okay, not all the background processes, but these are the critical ones in Oracle database. There will be hundreds of others background processes as well, but we are more or less concerned about these processes. Okay. From time to time, based on your requirement or because of some or the other functionality that you want to use, you will keep on seeing different kinds of background processes. Okay. Again, sorry, we didn't discuss about these two, MMNL and M1. Okay. So basically, these background processes come into picture for something called as database performance reports. Okay, so from time, if you want to find out how exactly your Oracle instance is performing, say how your shared SQL area or how your database buffer cache is performing, how your large pool is performing. Okay, so in those scenarios, okay, or how your database exactly is performing at any given point in time. So for that, we make use of something called as AWR reports in the database. Okay. And whatever information is getting populated in those AWR reports, okay, it is through these background processes, MMNL and M1, manageability monitor. Okay. So that is the functionality of these two background processes. So that's all about all these important background processes in case of Oracle database server. Okay. Now, these are the various file types that you get to see. Control files, now you know that it has got that checkpoint information, which is very crucial for performing instance recovery. Data files are your actual physical files on your system, which are holding all the data. Okay. Redo log files are the place where LGWR will write all those redo entries from redo log buffer. Okay. Those redo entries are required for performing a recovery in the database, right? Archive log files will come into picture when you have configured your database to run in archive mode, which means that, again, if I have to come back to the diagram.
Copying the redo log files from.
Exactly. So no, by default, your database operates in no archive mode. Okay. You can switch your database to run in archive mode, wherein archiver process will copy the redo entries to archive log files before it gets overwritten. Okay. So that is about archive log files. Flashback logs as well. Again, they will be appearing in your database only if flashback database mechanism has been enabled. Otherwise, they will not be existing. Trace files are, again, they will keep on generating automatically by itself. So that if at all there is some issue in the database, you as a DBA or even Oracle support engineers, they want to identify what is the issue in the database, they will make use of these trace files. Okay. Then the backup files are like backup of the databases and some or the other file types you will keep on saying. So these are optional file types, whereas these three are mandatory file types. Okay. Just give me a moment. I'll bring in the charger. Okay. So I'll assume that you guys have understood this Oracle database server architecture by now. Do you want me
It's
to
too
repeat?
complicated.
Sorry?
It's a too complicated. It's a too big architecture comparing to SQL server. But still,
Yeah.
we have to means take care of each and every point. Once we go through with the documentation, means while once again while we playing, if we take a notes, we will get to know that everything.
Yeah. So in case of Oracle, the architecture, it definitely has a lot of components that we as a DBA need to take care of. You are right in saying that. Okay. And mind you, this is only in case of single instance database, that is standalone databases. We are not even talking about a clustered architecture. Okay, in case of clustered architecture, you will see many more components over here, many more background processes, especially. There is not going to be much change inside the SGA or PGA, okay, but there will be many more important background processes that will come into picture for clustered setup. Okay. So do you want me, I mean, to do a recap or explain any of these components again, or you are good?
I don't require, but I can see the videos which you uploaded in our YouTube. I don't
Okay.
require it.
Okay, fine. So who was this, Azaz or Mahesh?
Mahesh.
Okay, what about you, Azaz?
Yeah, no problem. No, fine. I'm fine. No need
Okay,
to.
fine.
Yeah.
Fine. So just go through these videos maybe by tomorrow. Okay, by tomorrow, that should be the last session on Oracle Database Server Architecture. Okay. So I'll just I'll show you how we connect to the database or what we are actually going to do. in our practical sessions that we will start from maybe tomorrow or day after tomorrow itself. Okay. So this is how your setup will look like. We will install Oracle VM. Okay. And then on that VM, you are going to install Oracle Linux. Okay. Your base operating system will be Oracle Linux. And on that Oracle Linux, you will be installing the Oracle 19c database. Okay. So I have got one configured on my system, and this is how the interface looks like. Now, you must have used this Oracle VM for installing even SQL Server or some other VM tool, right?
Yes, yes.
Yes, yes.
Yeah. So, uh, just for you guys to know, I have installed this Oracle 19c on one of the systems over here. Okay. And if I want to say identify how many databases are running on my system, in case of Oracle, I'll fire this command. Okay. So if you see it over here, it says Ora underscore PMon underscore DB1. Okay. So if there are multiple, if there were multiple Oracle database instances running on this system, there would be another PMon process, and it would have name convention like Ora underscore PMon underscore some name over here. Okay. Now this is called as the instance name, or in case of Oracle, instance name is also called as SID. Okay. So
Mhm.
don't bother about all these commands as of now. Just have a look at it at this moment. Try to understand just, okay. You will get accustomed to firing all these commands. Okay. So if you want to identify what is the name of your database, then we make use of this parameter db underscore name. Okay, so through this parameter db underscore name, we specify what should be the name of the database. So while creating the database, I gave it a name as db1. Okay.
Okay.
However, there is another thing that you see over here, which is called as the instance name. Okay. So instance name and DB name, these are two different things. We will come back to our architecture diagram.
Hello. 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 Hello, Dhruva.
Yeah, yeah.
Uh, Not here. Hello. 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 Hello.
Hello. Hello.
Hello. Hello.
Hello. Can you hear me?
Yeah, I can.
Yeah. Maybe that is because I started that VM environment. The laptop is kind of getting hung. Okay, that's the problem.
Okay. How many
Okay.
database can be created in the server? Is there any limit or?
There, there is
Hello.
there is
Sorry, we disconnected once again.
such. Hello.
Hello. Hello. Hello. Hello, Dhruva.
Yeah, just a minute. I have to stop that VM. Hold on, please.
Okay.
Hello.
Yeah, Dhruva. Tell me.
Yeah, it was because the system was getting hung because of that VM. Okay. Just a minute. Let me pause the recording for now.